Hi everyone, I'm back again with another interesting geographical concept, which is heating and cooling of the atmosphere. So this concept is very important, especially for the UPSC civil service exam. As you all know that geography plays a dual role in the UPSC civil service exam, and it helps or assists aspirants to understand the physical features of the world. And on the other hand, it actually explains how human activity impacts and is influenced by these features. So this subject geography helps to create a strong base for other sections of the exam as well, which includes environment or the current events and especially disaster management. So learning the important topics in geography for UPSC prelims can significantly boost the chance of clearing the exam. It has been noticed that geography has been a consistent subject in the UPSC prelims with an average of at least 12 to 15 questions every year. Okay, so without much ado, let's quickly dive into the topic. I must have discussed this in my previous video. And to explain in detail, the Earth's surface is heated by the insolation process, the one that you see on the screen. I want you to be a little more, um, you know, careful with the arrows. Notice and examine the arrows while I'm explaining so that it becomes a little easier for you to understand the concept. Like I told you, the Earth's surface is heated by the insolation process. The amount of insolation received on the Earth's surface is not uniform at all. Okay? It is not uniform everywhere. Rather, it varies from place to place and from time to time. The tropical zone receives maximum annual insolation and it decreases towards the poles. What can be the reason? Definitely the shape of the earth. It's spherical in shape. It bulges at the equator and it becomes narrower towards the poles. So, and this portion of the earth, which is bulged at the equator, faces or witnesses or receives more amount of sunlight. Okay, and so that is why the tropical zone and the equatorial zone, they receive or they get maximum annual insolation compared to the poles, and it decreases towards the poles. Now, what are the various factors? One factor is definitely the shape of the earth. The other factor could be the rotation of the earth on its axis and the angle of inclination. It is inclined towards the sun at an angle of 66.5 degrees. That is again another reason. The length of the day, and another thing can be the configuration of the land. So all these are the various factors that influence the variations in insolation. So, what we should understand is that the air which is very closer to the Earth's surface gets heated first, and gradually heat is transferred to the upper layers also. So, this whole process of transfer of heat is called conduction. Okay, this process takes place when two bodies, okay, of uneven temperature. That is, when one particular body is cold and when the other part or the other body is hot. So that time we call it as an uneven temperature, and when they come in contact with another, there is a flow of energy from the warmer to the cooler body. This transfer of temperature continues until both the bodies attain equilibrium, or when they become equal in the temperature, that is both the bodies attain similar or equal temperature. That is when the contact is broken. Okay, so in this video, what we will do is we will learn in detail about the process of heating and cooling of the atmosphere. Okay. So the process of cooling and heating of atmosphere occurs in various process. Okay, it occurs in various process. First one is definitely the partial absorption of solar radiation by the atmosphere, the one that you see on the screen. Next is conduction, which I explained to you a while ago. And then the third one can be terrestrial radiation. Okay, so this next slide, this will talk about the Earth's energy budget. which is again another process of heating and cooling of the atmosphere. Then we'll learn about conduction, terrestrial radiation, solar radiation versus terrestrial radiation. Apart from that, we also have condensation, expansion, and compression of the air. So in this video, we will only focus on the first three concepts, and then the remaining three concepts I will explain in my next video. Okay, so the first topic here is partial absorption of solar radiation by the atmosphere. Okay, and this can be explained with the help of the next slide, which is the Earth's energy budget. Okay, so we call it Earth's energy budget. So heating of the atmosphere does not occur directly by the sun's rays passing through it. So you can see that it is very well evident on the screen. 10% of incoming solar radiation is absorbed by dust particles around us or water vapor. Okay, and the majority, which is 50% of this absorption, is done by lower 2 km of air where most of the water vapor is found. Okay, this process is not considered very effective in raising the surface air temperature. Because of this reason, even on a clear sunny day, the temperature near the surface remains very low. But in winter, what happens? The short wave incoming solar radiation is converted into long wave terrestrial energy. So you don't get confused, short wave and long wave. I'll explain in the further slides. But what you have to understand is that during the winter, the short wave incoming solar radiation is drastically converted into long wave terrestrial energy. And because of this reason, in winter, people enjoy the warmth. So you should remember that in winter, people enjoy the warmth of sunshine majorly because the short wave incoming radiation is converted to long wave terrestrial radiation. So you will learn that in the upcoming slides. So now solar radiation describes, so what is solar radiation? It describes the power emitted by the sun. Okay, and insolation, on the other hand, refers to the amount of solar radiation reaching the planet. That's the difference. Okay, however, as the sun's rays flow through the atmosphere, the upper layer of the atmosphere absorbs some of the heat. Okay, and terrestrial radiation is radiation emitted by the earth. Okay, so you have to know the difference between these three concepts in order to understand this concept, the heating and the cooling of the atmosphere better. You have to know these three important terms. Solar radiation, the next is terrestrial radiation, and the most important one here is the insolation. Okay, so solar radiation is the power emitted by the sun. Insolation refers to the amount of solar radiation reaching the planet. And terrestrial radiation is the radiation emitted by the earth. Okay, so the sun's rays, the land gets heated up. Okay, that is insolation. Once the land gets heated up, the land absorbs heat and the remaining of it is emitted back into the atmosphere. That is terrestrial radiation. Solar radiation, which we directly receive from the sun, and whatever is emitted back into the atmosphere by the earth is all terrestrial radiation. Okay, so this is in simple terms. So now we move on to the next slide to understand the difference between conduction and radiation. Okay, which again plays a crucial role in heating and cooling of the atmosphere. So in the conduction process, there occurs a flow or transfer of heat energy, again from the warmer object to the cooler object. So when two objects of unequal temperature come in contact, this heat flow process continues till the temperature of both the object becomes equal or the contact is broken. Okay, this conduction process occurs when there is a zone of contact between the atmosphere and the Earth's surface. Okay, so there's definitely a contact between the atmosphere and the Earth's surface. So this conduction process occurs when there is a zone of contact between them. So this method This method of heating only affects the air that is close to the Earth's surface. Okay, so this is all about conduction. So always remember, like the one that you see on the slide here, Radiation is nothing but the sun heats the ground. Conduction is the ground heats the air, and only that portion of the air which is very closer to the ground, which is very closer to the surface of the earth. And once the warm air rises, that process is called as convection. So this is the difference between radiation, conduction, and convection. So always remember, radiation is nothing but the solar radiation, insolation, process of insolation. When the sun's rays or when the sun emits power, okay, when it radiates heat to the surface of the earth, to the land, and the land absorbs enough heat, okay, once it absorbs enough heat, the remaining is radiated back, okay. So in the initial process it heats the air around, and gradually the warm air, okay, the warm air is usually lighter. We learned that in pressure in the previous video. So when the warm air rises, this process is called convection. So from radiation it's conduction, and from conduction it then leads to convection. Okay. So next we'll move on to the next most interesting part, which is terrestrial radiation. Okay, so what is terrestrial radiation? We must have learned this, okay? We've been learning this right from our lower classes, right? Terrestrial radiation, like I told you in the beginning of the video itself, when Earth's surface receives insolation in the form of short waves and heats up its surface, and after this process of heating, Earth itself becomes a radiating body. That is, the land here starts emitting heat. It returns the heat back into the atmosphere. That is why we say the earth itself becomes a radiating body. So it leads to radiation of energy to the atmosphere in the form of long waves. Now I told you I'll explain the difference between short waves and long waves, right? So short waves, what are short waves? Like I told you, when the earth's surface receives insolation. And it receives, how does it receive? It receives in the form of short waves. And these short waves heats up only the surface of the land. Now the next process is when the land is able to absorb enough of heat. And when it cannot absorb any more heat, what does it do? It emits back, it reflects back. And when it reflects back, it emits in the form of a long wave. Okay. So here the earth itself becomes a radiating body, emitting body. It leads to radiation of energy to the atmosphere in the form of long waves. And further, this energy heats the atmosphere from below. So this entire process is called or termed as terrestrial radiation. Now, another important thing that I want to share here is the atmospheric gases. Okay, mainly carbon dioxide and the other greenhouse gases absorb long wave radiation, and because of this, the atmosphere itself gets heated up. And then what happens? Further, what happens? The atmosphere transfers this heat to space, and at last, the amount of heat received from the sun is returned to space. Vice versa. Okay? The atmosphere transfers the heat to space, and at the last, the amount of heat received from the sun by the land is returned back. So that's the whole process of terrestrial radiation. So this whole process maintains constant temperature at the Earth's surface and in the atmosphere. So there is no change at all. So to explain that in a gist, the earth receives sunlight in the form of short waves, which heats up the surface. Now, as a result, the earth becomes a radiating body, emitting body. We know that. And it emits what? It emits energy to the atmosphere in the form of long waves. It received in the form of short waves, and now it's emitting back into the atmosphere in the form of long waves. Now, this energy warms up the atmosphere from below. Okay, and this process is referred to as terrestrial radiation. And the atmospheric gases, especially carbon dioxide and other greenhouse gases, absorb the long wave radiation. Okay, so I hope you understood. And to make it more clear, just highlight the points that is given to you. The difference between short wave. Most of the radiation has wavelength, which is given to you on the screen, less than 4 micrometers, which we generally refer to as short wave radiation. Similarly, Radiation that is emanating from the Earth's surface and atmosphere consists mainly of that having wavelengths longer than 4 micrometers, which is always termed as long wave radiation. So we've understood that the heating and the cooling of the atmosphere occurs through, various processes, which are conduction, convection, advection, terrestrial radiation. So in this video, we focused on three major areas, which is partial absorption of heat by the atmosphere. Then we also focused on conduction, and the last one was terrestrial radiation. So, what did we actually understand? What is our takeaway? So, these processes involve the transfer of heat through molecular movement, okay, and through horizontal hair movement and radiation from the Earth's surface to the atmosphere. Okay, and what is the major source of heat? Definitely the sun. The main source of heat for Earth and its atmosphere is predominantly the energy received from the sun. The secondary source can be, there are minor contributions from the Earth's cooling or, volcanic eruptions. And these sources are limited in their impact due to their, localized occurrence. But otherwise, these are the secondary sources, the cooling of the earth, hot springs, and volcanic eruptions. Solar energy plays a pivotal role, a very crucial role in distributing heat and energy across the globe despite various factors that influence its distribution. Okay, so like the one that you see on the screen here, this again explains to us all the three factors put together: partial absorption of heat, then comes conduction, and then the last one is terrestrial radiation. So the incoming solar radiation, which is 100% from the sun, is received, and and only 51% of the insolation is absorbed at the surface. Okay, so the land absorbs 51% of the incoming solar radiation, 19% is absorbed by the atmosphere and the clouds, and the remaining is reflected from the surface. So here, the surface of the earth acts as a radiating body, emitting energy or emitting the power or the insolation that is received from the sun. So it is reflected back into the atmosphere, that is 4% from the surface, 20% is reflected by the clouds, and 6% is reflected by the atmosphere.